Hey folks, today we are graphing, this should say systems of linear inequalities. So you might remember from last module, we graphed inequalities, linear inequalities. That was where, remember these 3 steps, you're allowed to use that as on the back of your reference sheet that we were allowed to use on the test there. So we're going to start off, it's the same kind of idea. We're going to graph the boundary line. Remember, if it's less than or greater than, it's dashed. If it's less than or equal to or greater than or equal to, solid. Then after we draw the line, we test a point. Preferably you try 0, 0, and then you shade the true side. So for instance, here's this first inequality. We graphed it. We tested 0, 0, and it turned out to be false. So 0, 0 in this case was false, so we shaded in this side over here. Now last time that was it. We were done after we shaded in one side. But now we're graphing a system of inequalities. So we would graph two inequalities, I'm sorry. So we start off, this is the one that I just talked about over here. So I graphed this boundary line. We test a point and we shade in this spot over here. Then we had another inequality. We graphed that boundary line. We tested a point and then we shaded in the appropriate side. So we shaded in this part here. Today what we're talking about is the solution to the system. If you remember when we did systems yesterday, we figured out the solution to the system was where the two lines intersected each other. So in this case, we are highlighting the part that's highlighted by both the orange and the green part of the graph. So this is the solution where they intersect with each other. So this down here was a solid line. This over here was a dashed line, and then we would highlight that section there. That's what our goal is today. We're trying to highlight the solution to the system of inequalities, the place that is covered by both pieces of the inequality. So like if I was to delete the other part, if I was to go back, what I really should do now is I should go back and erase those two things, and it should look like this. If you leave them on there, I'd still give you full credit, that's fine. Okay, so let's jump into it. So here we go. We've got this. We've got two inequalities here. These inequalities are both in standard form. You might remember the best way to graph in standard form is to do the cover-up method. So I have x and I have y. I'm going to plug in 0 for x. That means I cover up the x part of it, and it says negative y equals 3. If I solve that, I would get negative 3. Then I put 0 in for y. That means I cover up the y. To solve that, I would divide by 2. 3 divided by 2 is 1.5. So my graph is going to hit at 0, negative, let me slide this up a little bit, 0, negative, 1, 2, negative 3, and at 1.5, 0. Okay, so this be solid or dashed. The way I figure that out is I look at the inequality. This is greater than or equal to. So I'm going to connect this with a solid line. Now, before I shade anything in, I got to test a point. So I'm going to take the point 0, 0, and I'm going to plug it into this equation. So that would be 2 times 0 minus 0 is greater than or equal to 3. Well, 2 times 0 is 0, minus 0 is 0, so I get 0 is greater than or equal to 3. 0 is not greater than or equal to 3. This is a false statement. So that means the side that 0, 0 is the wrong side, so I'm going to shade in the correct side. So I'm going to shade in everything over here. Now, like I said earlier in the video, before that was the end. We would stop there and we'd be done. But now we're graphing a system of inequalities. That means that we have two equations that we have to graph, or inequalities we have to graph. So again, this is in standard form. X and y are on the same side, so I'm going to do the cover-up method. I'm going to put a 0 in for x. That means I cover up the x. So it now says negative 5y, and we just pretend like this is an equal sign. Negative 5y equals negative 5. If I solve that, I would get a 1. Then I put a 0 in for the y. I'm going to cover up the y part of this. And it just says x, so the game's over. X equals negative 5. I'm going to graph these 2 points. 0, 1 is here. Negative 5, 0, 1, 2, 3, 4. Negative 5, 0 is there. And then I'm going to look. This tells me that we're going to do a dashed line. less than or greater than is always going to be a dashed line. Now I don't know which side to shade yet, so again, like we've done before, I'm going to test a point. I'm going to plug in 0 for x and 0 for y. So that would be 0 minus 5 times 0 is less than negative 5. 0 minus 5 times 0 is 0. Is 0 less than negative 5? No, that's also false. So that means here's 0, 0. On the blue line, that's the false side. So the correct side, the true side, would be this side over here. So basically, we just do the same thing twice, and then we go and we highlight the part that we shaded in both blue and in red. This was a dashed line. This was a solid line. And then we shade in that section there. That's the solution. Okay, let's try another one. We've got another one here. This time it says y, and y is by itself, so that's in slope-intercept form. So I'm going to try to graph this thing in slope-intercept. That means I should be able to figure out what the slope is and what the y-intercept is. Okay, so the slope is the thing connected to x, the whole thing connected to x. In front of x, there's a hidden 1, and underneath it is a 2, so that's 1 over 2, that's 1/2. My y-intercept is 3. So I'm going to start at 3, 1, 2, 3 on the y-axis. My slope is 1 over 2, so that's rise 1, run 2, rise 1, run 2. And then the reverse of that would be down 1, back 2, down 1, back 2. All right, solid or dashed? Should be dashed. So now I'm going to go and dash that line. I can't figure out yet which side to shade until I test 0, 0. So I'm going to plug 0 in for y and 0 in for x. So that would say 0 is greater than 0 over 2 plus 3. 0 is greater than 0 over 2 is 0, 0 plus 3. And if you need a calc, go grab a calc. You can type it in there. Is 0 greater than 3? No, that's false. So that means this side where 0, 0 is the false side. And that means this side over here is the true side. I'm going to encourage you to pause here. Pause and see if you can make the sketch of this second one. All right, let's see how you did. Again, I'm in slope-intercept form. Y is by itself. So m is equal to negative 2. My y-intercept is negative 4. Okay, so I'm going to begin at negative 4. 1, 2, 3, negative 4. My slope, if your slope isn't a fraction, you always want to make it a fraction. You can make anything in a fraction by putting it over 1. So now I'm going to rise negative 2. Well, I can't rise negative 2. So I'm going to have to do the reverse. Instead of going down 2, forward 1, I'm going to have to do the reverse of up 2, backward 1. Up 2, back 1. Up 2, back 1. Up 2, back, up 2, back. All right. This time it's greater than or equal to, so I know I'm going to draw this with a solid line. And now I don't know which side until I test 0, 0. So let's plug in 0. I'm going to plug in 0 is greater than or equal to, I'm going to do this part in my head because I don't have enough room. So negative 2 times 0 is 0, minus 4 is negative 4. Is 0 greater than negative 4? Yes, that's true. 0 is greater than negative 4. So the 0, 0 side is the true side. So this time I'm going to shade in like this. Okay, now that you've shaded both of them, go back with a different color if you've got it, or just write it with real bold. The part that they share. So this was a dashed line. This was a solid line. And all of this is the pieces that they shared. I think this is getting kind of repetitive at this point. If you want to go ahead and do this one, you can do this one. I'll pause the video and show you what the answer looks like. If you want to do it, go ahead. If you feel like you know what you're doing, you can if you feel like these two are enough, you can skip it. There's the first equation. That was in standard form, so I did the cover-up method. My other equation is in slope-intercept form. So I did my slope, I did my y-intercept. This one was dashed. I tested. 0, 0 was false. So I graphed that one. And now I'm going to highlight the piece that they have in common. That would be a dash line here, dash, dash, solid there. And then I'm going to highlight all of this as the purple and the brown part together. Okay. Write a system of inequalities for the situations, but do not solve them. So what I want to do here is, we've done, like, you could keep doing this, but I just want to practice how to write this stuff up. If you've got a story problem and you're trying to turn it into math, you always want to start off by figuring out what are the variables. What are the things that are changing in this story? What is X? What is Y? Okay, so a basketball team is raising money by washing cars. Their goal is to earn at least $700. But they only have time to wash no more than 150 cars. Okay, so they want to make $700, but they can't wash more than 150 cars. They will charge $5 for a basic car wash and $8 for a car wash plus waxing. So what are the things that what are the things that are going to change? What are the things that are going to make these people or this basketball team money? Well, the number of washes. They got to make a certain number of washes to make their money, but there's different kinds of washes. So let's call the first one the X. We'll call that how many, the number of basic washes. And then that means Y then will be the number of wash and wax. So now that we know what our variables are, we're going to try to turn this story into two different equations, because there's two parts of the story. There's the money part, and then there's the amount of cars that they can do. They want to make at least $700. Well, what makes the money? How do they earn money? They earn $5 for every basic. So $5 times how many basic washes did they do? X. So it's 5 times X plus how much does a car wash, wash and wax cost? $8 plus how many did they do? And that money plus money should come together to make money, needs to be greater than or equal to $700, because they said they want to make more money or at least equal to 700. So it could be more or. Now, they also have to make, they can't do more than 150 cars. They run out of time. So the number of washes that they do altogether has to be less than 150. There are X basics, there are Y wash and wax, and that cannot be more than 150. Now what we would do if they said to continue this, you would do the cover-up method. You'd find your X, you'd find your Y, you'd plug them in, you'd go graph it, and then shade in the appropriate spots. Okay, I'm going to encourage you to pause here and see if you can figure out what the X and Y stand for. What is X going to be? What is Y going to be in this story? All right, let's see how you did. Okay, X is going to, Zoe wants to buy gift cards and present them to her friend as a presents for her friends. A gift card to her favorite restaurant costs $15, and a movie theater gift card costs $25. She wants to buy at least 5 cards and spend at most 2. There's the two equations. There's going to be 5 cards bought altogether and doesn't want to spend more than $200. That's going to be my equations. But we first have to figure out what are the variables. The things that we don't know is I know how much it costs to go to her favorite restaurant, but we don't know how many of these gift cards she's going to buy. So X would be the number of restaurant gift cards. And I know how much a movie theater gift card costs. It's $25. That's not unknown. What I don't know is how many she's going to buy. The number of movie gift cards. I'm going to encourage you, now that hopefully you did that on your own. If you didn't, hopefully that made sense. I'm going to encourage you again to pause and see if you can write up the inequalities. All right, let's see how you did. She wants to buy at least 5 cards. So the X stands for how many cards to the restaurant she buys, and Y stands for the movie gift cards. So if we take X and we add Y, those are the gift cards. The number of gift cards has to be... Oh, she wants to buy at least 5 cards. I think I read that wrong. So she wants to buy 5 cards at the bottom and make more. Oh, that's a good friend. So the amount of cards that she buys has to be greater than or equal to 5. If she wants to buy at least 5, she wants to make more than 5, or buy more than 5. 5 or more, I should say. Okay, she wants to spend, though, at most $200. So if I want to now figure out money, I got to use money. So gift card restaurant is X, but that costs $15. So that would be 15 in X plus a theater gift card is $25, so that would be 25 in Y. But she doesn't want it to go above 200, so she wants it to be less than or equal to 200. Okay, there's a couple of problems on the homework that you're going to need graphs for, so I put just some blank graph paper on the back so that you can use those on the homework, and good luck.